Okay, this section is called 7.2 Areas in the Plane. When you find areas of any two functions, there are two ways to do this when you set this up. It's either going to be top minus the bottom or right minus the left. So looking at this equation right here, this is my top equation right here, and this is the bottom equation right here, which is that x squared minus 4x right there. And we can see that when we shade it, it's all of this top right here is shaded downwards right here, and it meets to the bottom part of the graph. So I'm going to use this top minus the bottom part of it. Now to use the right minus left, it's going to be more obvious that it's going to be like a sideways parabola right here. So you'll have like a right equation and then probably a linear equation or something like that. So that way you can do right minus left. But in this one, it's obvious it's going to be top minus bottom. So we're going to go ahead and set this up as top minus bottom. Now when we take area of anything, it's going to be an integration problem. So we're going to set this up as an integration. So here we go. It's integration of, and then we said the top equation is y plus 6, and then the bottom equation is x squared minus 4x right there. So this is the dx. Okay, and I'm going to put a little top for t right there, and then the bottom, just to remind myself there's two equations right there. So that's how we got the top and the bottom right here. Okay, now we need to have is the limits, the lower limits and the upper limits. So then, oops, there should have been an x right there. Okay, so then from here, the variables in the equation are x's, right? Because this equation has an x and this has an x. So when we take the limits, the lower limits and the upper limits, we need to take the limits of the x numbers. So we have then is -1, because that's the tip of right there where the area is beginning right there. And then all the way up to 6 right there, so that's the end of that area right there. So the lower limits are going to be from -1 to +6. Okay, so now that's going to be just the simple integration from here. So let's just go ahead and I'm going to distribute this negative in and combine like terms and all that stuff right there. So -1 to 6, and I have is then x plus 6 minus x squared plus 4x. Oh, this is still dx right there. And then we combine like terms because I can see that an x and a 4x can combine right there. So then we have is -1 to 6, and that's going to be, let me put it in order, -x squared plus 5x, and then plus 6, and then dx right there. Okay, so now I'm ready to take the integration. So now the integration of that becomes what? -x to the third power, right, divided by 3, plus 5x squared over 2 plus 6x, and the limits are from -1 to 6. Okay, so we're going to do the substitution for each of those numbers right there. So I'm going to have then is -6 to the third, right, all over 3, plus 6 squared all over 2, and then plus 6 times 6. And then we put little brackets just to remind myself. That was just the limits for the 6. So I just substituted to all the x's right there. And then minus, because that's going to be your, this is your top part of it, right? And so then minus the -1. So we have this -1 to the third power divided by 3 plus 5, -1 to the second power, and then plus 6 times -1. Okay, so for sake of time, we're just going to calculate this already, and that's going to come out to be 54 right there. And this is a minus, and this comes out right here to be a -3.1667 right there. And so then from here, obviously this is negative and negative, so they're going to add together, and that becomes 57.1667. Is your final answer right there. Okay, so we're saying that this is the area of all of this part right here, the shaded right here. Okay, all right, now let's try example number 2. So example number 2, we're going to have this equation right here. Now, if I use that same method that we just mentioned about using either top minus the bottom of the area or right minus left, we have a problem in this situation. Because if I take the top right here, and if I minus the bottom is, I think, this one down here, right? But then if I do top minus the bottom of the area, what it's going to happen is it's going to shade all of this right here, and including this piece right here, which I don't need all the way up to the 4 part right here. Okay, so that's not what I want. So if I try to do right minus left, I take this right equation and I subtract it from this left equation and it looks good. But remember, this goes down all the way down and has to meet the y-axis. So it's actually going to find the area of this bottom part right here, which I don't need right here. So in this case, in some of the situations, we're going to have to split the equation up or the picture up so that way we can actually get a better area right here. So I'm going to split it up into two parts right there. As you can see right there, I call this part 1 and then part 2. So I'm going to split it down this way right here just because then I can see that this is actually the top minus the bottom part of this equation right here. And I can still do top minus bottom right here because this is going to be obvious that it's going to shade downwards right here. So that's going to be your top minus the bottom. Okay, so then afterwards we're going to add these two equations together and then get your final answer for the area of this whole thing right here. Okay, so then let's go ahead and do that. So I'm going to split it up into, I'm going to call this part 1 and take the integration of that. So then it becomes the integration of the top equation, which is the square root of x right there. So it's square root of x minus, and then this right here is what? Y equals 0 right here. So I'm just going to put 0 just because I know some people need to see that. And so this is going to be right here dx. So this was the top minus the bottom part of the equation right there. Okay, and then the limits. So the limits is from 0, 0 right here, and then it meets all the way up here at 2, 0. So we want just the x numbers because it has a variable of x right here. So it's going to be from 0 to 2 right there. Okay, so this is a simple integration. So let's fix this up. I'm going to go from 0 to 2, x to the half power, right, dx. So when I take the integration of that, that becomes x to the 3/2, 2/3, right? Multiply the reciprocal of the exponent right there, and then from 0 to 2 right there. Okay, so we do some substitution now. So then it becomes 2/3, 2 3/2 right there. And then the 0 I won't even bother because it's not going to affect it. Now, if I had something else afterwards, like a number or something like that, definitely put in the zeros because it will affect the equation right there. But in this case, the x receives a 0 right there, and it's not going to affect anything. If anything, it just cancels out to 0. So it'll leave it like that. Okay? All right, now number 2. So this is the second part, which is this part right here. So we're only finding the area from where that cutoff is right there. So from here to here, we're finding all of this area in this part right here. Okay? So we still want to do is the top minus the bottom in this equation. So my top equation still is the square root of x right there, minus, and then the bottom equation is going to become x minus 2. And always put parentheses in the second part of the equation because you can see right away I'm going to have to distribute this negative into the second part right there. Okay, so make sure you do that. And the limits are from, lower limits are from 2 to the upper limits, which is 4 right there. So we're going to go from 2 to 4 right there. Okay, so let's go ahead and simplify that before I actually take the integration. So I'm going to take this to the half power, distribute the x right there, plus 2, right, dx. Okay, so now I can do the simple integration. So then it becomes, again, this is going to be, what, 3/2 again, 2/3, right? And then minus x squared over 2, and then plus 2x. The limits are from 2 to 4 right there. Okay, so then we're going to substitute each of these right here. So we have is then 2/3, 4 3/2 right there, and then minus 4 squared over 2 plus 2 times 4. And then I'm going to put a little bracket just to remind myself that was all just the 4s. So the substitutions for all of this x right here was for the 4s. So then minus, and then we do the same thing for the 2s now. So it becomes now 2/3, 2 to the 3/2 minus 2 squared, 2 squared all over 2 plus 2 times 2. And again, that was just for the 2s, okay? All right, so now the calculations. So the calculation goes something like this, where now we have to deal with is the radical up here. So maybe I'll walk you through with that one right there. So I have then is 2/3 right there, and I have is, I'm going to put this right here inside the square root. So remember, the top part of the fraction is inside and then outside right here. So I go in and out right there. So 4 to the 3rd, right, is in, and then 2 is on the outside right there, okay? So minus, and then 4 squared is 16, divided by 2 is 8, plus 4 times 2 is 8, so all of that's right there. And then we have is minus, And then do the same thing for this one right here. So we have is 2/3. Oops, the radical right there. So 2, 3 inside, 2 on the outside right there, right? And then I have is minus 4, right? Divided by 2 is 2 plus 4 right there. Okay, so that's just this part right here. All right, so now we need to simplify. So this right here simplifies to a positive 2. The 8's cancel out right here. So then we're just dealing with the radical right here. So 4 to the third, 4 to the second is 16. 16 times 3 is 64. And then the square root of 64 is 8, right? So we just have then as 2/3 times 8 in this case right there. And then this one right here will be 2 times 2 to the third is 8, right? So in this case, I think we're going to have to leave 2 out. So I'm going to do a little my factor tree thing again. So 2, right, there's 3 of those. 2 of these come out right there. This is going to stay inside. So that's going to give me 4/3 right there times the radical 2 inside minus 2. So I'll distribute this negative right here, minus and plus right there. And I still have that, which is 16/3. But remember, this right here is just for part 2, right? And we still have is the part 1 right there. So let me finish this part 1 up because we're going to have to add those together right there. So this is 2/3, and then we have radical 2 to the 3 and out, right? So this is 8 right there. Oh, wait, that's similar to what we just did right here, right? So I think that's going to cancel each other out right there. That one and that one's going to cancel out. So I don't have to worry about that one, finishing that one up. So I just need to finish up is 16/3 and then the 2. So let's deal with that fraction. So 16/3 plus 2 right there. So 2 needs a common denominator, 3/3, right? So that's 10, or sorry, 6. Wait, so 6. And then from there, oops, I forgot something. I got a feeling I forgot something. I know what I forgot. Okay, so this right here should have been -2. I'm sorry, positive 2. So because of this distribution right here, that's going to be a -2. So there we are. Okay, so then that's a negative, and that's a negative right there. So that's going to give us 6 right there. So 16 minus 6 is 10. So then 10/3 is the final answer right there. Okay, so let me walk you through on this second problem right here, just because it's a little bit more process-wise. So process we did was the first part right here. We took the first integration, top minus the bottom, right? That's the setup right there. Had to deal with some calculations right there. And then we broke it down for this one, top minus the bottom again for the second part right here. So we did, here's our top equation minus the bottom equation right there. Let's put t minus the bottom. Okay, then I had to deal with the simple integration right there. So we deal with the simple integration, and then we had to do some substitution. So that's what we did right there. And we had some radicals to deal with. So with radicals, if you ever deal with radicals, the top part of the fraction, which is the numerator, is going to be the inside of the radical, and then the outside or the denominator is going to be on the outside. So I always go in and out, right? So in and out. Just remember in and out. So in and out right there. So when you deal with the radicals, things should cancel out easily when we deal with something like this. So don't work too hard on this. Just make sure when you go back and check your work on this, okay? All right, so now let's try the classwork problems.